Hey everyone, Professor Michael Scanlon here, right here, coming to you with an experiment that you can really sink your teeth into. We're talking cooking. Now, we're not actually going to apply heat to anything today. I want to talk to you a little bit about some of the chemistry that you see in your classroom, or sorry, not in your classroom, in your kitchen, although if you teach chemistry, you'd see it in your classroom too. So, I want to talk about special types of mixtures called emulsions. Now, if I have water, as I do here, and I add some oil to it. Now I'm just using cooking oil, vegetable oil. Any oil will work, but this is a pretty common one that most people are going to have. I'm going to see that these two do not mix. They don't like each other. You could shake this up really hard and get it to redistribute. Think of Italian dressing for your salads. You're going to have some oil on the top, some not oil on the bottom. Check out what that is. And you shake it up, and you wind up with a temporary suspension. But over time, the oil will separate out again. And so I could put this in a different container and shake it up, and the oil and the water would sort of distribute amongst one another, but they would separate rather quickly. How can I get it so that they're going to stay? And that's what we would call a stable emulsion. Well, to do that, you would need a third thing, a third compound, a third chemical, a third whatever you want to call it, called an emulsifier. Now, a very common one that you're going to run into in your kitchen is the egg. A lot of applications that call for eggs are actually using their emulsifying properties to hold together materials that don't normally go together. Now, is an egg the only emulsifier? No. In fact, you see emulsions every day around you. I highly recommend you check them out and look it up and see where you see these all the time. So I've let my oil kind of stabilize and quit, bubbling up or whatever. And now I've got this nice thick layer of oil on top and a layer of water on bottom. I'm going to crack my egg. Now it's really the egg yolk, but you can go through the hassle of getting the yolk out by itself. It's not really that difficult, but these videos are supposed to be short. I've only got one egg. So for the sake of science, trying so hard not to make a mess because I've only got one egg. For the sake of science, come on, crack. You are a stubborn little egg. There we go. Scared me. Crack the egg, throw that on the floor. I'm lying, there's a trash can right there. And I'm going to stir, I got an eggshell in there, naturally. I'm going to stir it up. I can crack the yolk. There we go. Now, once I get the yolk open and exposed to the rest of the solution, I stir it up. You notice a couple of things happen. I don't have layers necessarily anymore. And the material, the solution changes color. Now, this isn't strictly speaking a chemical reaction. This is the egg yolk suspending the oil droplets in the water. And so that creates this kind of milky color. Milky. That was actually a big hint. Check it out. So anyway, with an emulsifier, I have been successful in making two things that don't normally want to go together actually go together. And I wound up with a mess. Be careful with this because you can and probably will make a mess if you try it at home. Look up emulsions and see how useful, practical, and prevalent they are in your everyday lives. That's it for this one, everyone. Thanks for watching. I'll see you in the next one.